Hello, welcome to this session taking on cyclic quadrilaterals, this being the last view portion on the circle. What we take up is will be the theorems. Before moving on to the theorems, let's understand what is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral whose all the four vertices lie on a circle. If you see, this is a cyclic quadrilateral wherein this A, B, C, D, the four vertices lie on this circle. Let's take up the first theorem under this. It says a cyclic quadrilateral, the opposite angles of a cyclic quadrilateral. Oh, I made a spell mistake. Yeah, I rectified it. Quadrilateral are supplementary. Supplementary means the sum of the opposite angles will be 180 degree. Let's take up the same figure, continue with the same figure. To do so, let's join BD, a little one, BD and AC. I write here first. To prove, what we need is angle A plus angle C is 180 degrees and angle B plus angle D will also be 180 degrees. To do so, now look at this AB as a chord. If you look at AB as the chord of the circle, we can clearly see, either I might just highlight it with another color. Now on this AB, angle ADB is drawn, and on this ACB is also drawn. We have learned previously that angles drawn on the same segment are equal, so thereby making angle ADB it's equal to angle ACB, and in the bracket you can write angles in the same segment. On the other hand, if we take BC as the chord, the two angles drawn will be BAC and CDB, right? So CDB will be equal to CAB, alright? In the same reason, being angles on the same segment, this time we have taken the segment to be BC. Now if we add these two, what do we get? We get angle ADB plus angle CDB is equal to angle ACB plus angle CAB. Now look at angle ACB on the right hand side and angle CAB as well. Now if I add angle ABC to this side, it completes all the angles of a triangle. So I'll add ABC to both the sides. Now if I do so, the right hand side, as I just said, the right side becomes the sum of three angles of a triangle. So angle ADB plus angle CDB plus angle ABC. I haven't yet concentrated on the LHS part. We have now moved on to prove this to be 380 degree. Now look at this part. ADB plus CDB makes it whole angle D. And ABC can also be written as whole angle B. That makes it 180 degree. This was our first proof. Angle B plus angle D is 180 degree. Now, on the other hand, we know in a quadrilateral, the sum of all the angles is 360 degrees. Now, if you rearrange, it can be written angle B plus angle D plus angle A plus angle C as 360. Out of this, we have proved B plus D to be 180, so I substitute it with it, and the rest is left as A plus C, that's 360. So angle A plus C will be 360 minus 180, and that also giving us 180. So we got our second proof as well. Once we are done with it, let's move on to the next screen for another theorem. I write it down here. It says the quadrilateral formed by angle bisectors of a cyclic quadrilateral is also cyclic. We need to draw a cyclic quadrilateral. We'll also be drawing the angle bisector of the vertices. So this we name as A, B, C and D. Let's draw the angle bisectors, and if we draw them accurately, though not this one, they will more or less look like this. I need to clear this up. Okay, and also C and D's now we have to name them as well. I name this as P, this point of intersection to be Q, this as R, and this as S. So we have to prove PQRS, though my figure might not be accurate. We have to prove this PQR is to be cyclic. That means either we prove P plus R to be 180, or we can prove S plus Q to be 180. I write here. What do we have to prove? We have to prove PQRS is a cyclic quadrilateral. For our understanding, we can write here, what do we prove? We prove angle P plus angle R to be 180. Either one of them can be, proved. We don't need to prove both of them, because automatically, on the other hand, S plus Q will become 180 degrees. At least this we need. Now move on to the proof. Look at the triangle APB. In that triangle, I write in triangle APB. What can we write? We can write angle APB, this small one, this one, plus angle PAB plus angle PBA is 180. It's angle sum property. On the other hand, if you take the triangle CRD, in triangle CRD, what do we get? We get angle CRD plus angle RCD. This one and these two. RCD plus angle RDC. That also gives you 180 because of the same reason, angle sum property. Now if you see, we can substitute this PAB as half of angle A, this one, because this PA, they are actually angle bisectors. So I can substitute and write this one as well. The first equation can be written as APB, PAB can be as half of angle A. Similarly, PBA can be expressed as half of angle B. That should be giving us 180, because we are simply substituting this in the second one as well. I'll do. Let's see our DB as it is. RCD can be expressed as half of angle C, and RDC can be substituted with half of angle D. They are all our bisectors. Now we will add both these two equations. If we do so, what do we get? Angle APB plus angle CRD plus half of angle A plus half of angle B plus half of angle C, or I can write A with C, that would be more convenient for me. Then half of B plus half of D, that gives 360 degree if I add the right hand part as well. Now APB, let it remain as it is, plus I can take half common, thereby leaving me with A plus C plus B plus D. Now we know A plus B plus C plus D, that's 180 degrees. So angle APB plus angle CRD is actually half of 360 here, and that should be 180. So actually if I take 180 from it to the other side, it becomes APB plus CRD to be 360 minus 180, and the equation we get will be writing here. So it is angle APB plus angle CRD is equal to 180 degrees. So we got to prove this angle and this angle added to 180 degree. So automatically even S plus Q also becomes 180 degree, thereby making PQRS a cyclic quadrilateral. Hope you followed it. Thank you.